So in this video, I'm going to discuss the maximum and or problem which occurred in today's CodeChef challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. The problem statement is very simple. It is given that this is the number of test cases, and this is you're given three elements A, B, C. I mean three numbers A, B, and C, and there is a function f of PQR which actually means that it is R or P minus Q and P. So you have to find out the maximum value of f of x comma a comma b, and for and so you don't have to find out the maximum value for this. So you have to find out how many values of x gives the maximum value for this, where x is in the range of this. Okay, 2 to the power c. So this is a very nice problem. So whenever you see that there is a 2 to the power c from 0 to 2 to the power c, so we know one thing, that the bitwise representation of this number is obviously going to fit into into something which is of length c. Okay, which is of length c. So this thing is very much clear about it. So now comes like the truth table. Okay, so let's say I don't know what is x. Okay, since this is a bitwise operation that we have to perform, so we are going to consider each and every bit and the possible values that we are going to get. So truth table, I think you know how to make it. So this and this is basically like, let's reframe it. This is R or P, so that is this or this, that is B or X, that is B or X, minus Q and P, that is this and this, that is A and X, that is A and X. Okay, so I hope this one is clear. So let's draw the truth table. So this is 0 0 0, this is 1, this is 0 0 0 0, and this is 1 1 1 1. So this is 1 1, this is 0 0 1 1 0 1 0 1 0 1. So now let's check this out. So this is, so in spite of writing this as this, we can write it b dot x minus, sorry, b plus x minus a dot x, right? Remember, this plus means the OR operation, not, and this minus is the arithmetic operation, minus. Okay, so b plus x, that is 0, minus a dot x, that is 0, so that is 0. So for this, b dot x is 0 minus a dot x, that is also 0, so this is 0. b dot x minus a and x, so that is, now see, now there's very nice thing. Okay, so this is b plus, right? Sorry, actually I made a mistake. I think this was, I made a mistake over here. So this was b plus x, so that is 1 minus a dot x, that is 0, so that is 1 actually. Now this is b plus x, that is 0 minus a dot x, that is 0, so this is 0. Now again b plus x, 1 minus 0, so that is 1, right? Now this is 1 minus 0, that is 1. This is b plus x, that is 1 minus 0, that is 1. Now over here b plus x, that is 1 minus 1, that is 0, right? For this it is 1 minus 1, that is 0 again. So now see, you can see one thing, that for 0 0 of a and b and 0 0 of a and b, so once we make it 0, it is 0, and if we make it 1, it is 1. So for to make this maximum, I have to use this 1, right? We can't use this 0. So, and for 0 1 condition, so that is this condition, no matter what we do, the answer is 1, right? So over here there is a contradiction. So let's say this is a contradiction, so I'm going to make it as a question mark. Okay, and for 1 0 also it becomes 0 irrespective. So over here also there is a contradiction. So we can either, for these two cases, we can either use 0 or 1. It doesn't make sense, the thing will be same. But for 1 1, see, 1 1, for 0 it becomes 1, and for 1 it becomes 0. So for this, obviously we're going to use this, right? And for this, we are obviously going to use this. But for these two cases where A is 0 and B is 1, or A is 1 and B is 0. So for those two cases, you have to make, you can use any one of them, right? Any one of them. So now there's the concept, like if you see the answer, it is very simple that all these answers are in a form of 2 to the power x. Okay, what is x? X is the number of positions of this bit where A and B, the bitwise representation of A and B, has A is either 0 and B is 1, or B is 0 and A is 1. So how you're going to do it? You're going to find out the bitwise representation of A and the bitwise representation of B. So let's do it with this one. This one is very big one, so we can't do this like for now. So for this A, so 1, what is the bitwise representation of 1? It, we know it, right? It is 0 0 0 0 1, but since this is 3, so we have to fit it in 3 blocks, so this will be 0 0 1, right? And for 2 it is 0 1 0. So how many positions have this condition, that is 0 1 and 1 0? So there is this one condition, one place where this is 1 0, and one this place where it is 0 1. So there are 2 places, right? So what is 2 to the power 2? It is 4. For this 0 0, so it is of size 2, so it will be 0 0 0 0. So none of the conditions are like that. So over here it will be 2 to the power 0. So what is 2 to the power 0? It is 1. So this is basically 2 squared. This is basically 2 to the power 0. And this thing, like if you see the binary representation and put it in a box of 15 blocks, so you will get to know that the answer comes to be like whatever the answer is, it will be 2 to the power, I guess, 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. So it is 6, right? So it is 2 to the 6. So there are 6 positions where we are going to get a 0 1 or a 1 0 for these 2 elements. You can check it out manually. So this is how this code works. So I hope this is very much clear to you. So this is the basic logic behind this code. This one was a very nice problem, so try to solve it.